capture a particular scene. Okay, right? So how do we capture a particular scene in the sense, right? So for example, we will be just right. So we may be watching something with our eyes, right? So for example, we may be watching, we may be enjoying the nature, right? So whenever we see the nature, right, so, that particular scene will be available to us, uh, will be available to us in a what I can say, in a larger window. In a larger window, right? Whatever our eyes can visualize, right? What that is the angle, that is the maximum angle that our eyes can visualize is the window for me. Okay, right? So towards left, towards right, and towards straight, what all the to what length and to what height my eyes has the ability to visualize the scene, right? Is the window for me, right? So when I try to capture that, right? So with a camera, right? If that means when I go when I take the camera and when I try to see the scene within through the camera, right? So how does that particular scene get visualized to you in the camera, right? As a very small window. Correct, right? All those things, those which are visible to us with the bare eyes, right? As a very big thing, right? Those will be available. Those will be seen through the whenever we see through the camera, right? Those things will be seen very as a very small things, right? And when we capture those things, right, that means whenever we click the aperture, right, so what happens, right, that things comes as a photo for us, right? So now what is our today's discussion is, right, how does that particular photo comes to us, right? Whatever we see with the bare eyes, right, our viewing window is very big. Okay, right? But the viewing window of my camera is very small, and whenever I capture those things, right, those things comes to me as a photo, right, which is of length 4 by 6 or 8 by 16, right? So something of size, right? So which are very small as with respect to what I have seen. Correct, right? How does actually my camera takes the photograph, right? And whenever it takes the photograph, right, all the things that I see, fine, right? So those things will be proportionally small in the photograph. Correct, right? So for example, if I am seeing some two persons, right? So one person is a fat person, another person is a lean person, right? So whenever I take the photograph of those two, right, so it comes to me in a appropriate manner. Okay, right, it comes to me in appropriate manner, in the sense, right, it will be whenever I see that photograph, right, I can clearly visualize the same thing what I have visualized with my eyes. Only thing is, right, proportionally the things will be altered small, right, because my photograph window is maybe 4 by 6 photograph window of the photograph the frame. Okay, right, yes, sure, 4 by 6 or 8 by 16 or but our viewing window or our viewing angle will be large. Okay, how actually that happens to us, right? So that is what today's discussion is. Fine, right? So today's discussion is all about yes, that is what about today's discussion, right? So the question that they will be asking for you, the question that they will be asking for you here is like this, right? So explain the transformation from local coordinates to device coordinates. Okay, right? So local coordinates are what we see. Okay, whenever we see a particular scene, right? So those scene will not be available for me as a circle, or those scene will not be available for me as a sphere. That scene will not be available for me as a cylinder. Okay, that particular scene will be visible to me in a 2D fashion, rectangular fashion. Agree with me, right? So if I see a nature, or if I see a building, if I see for example, if I see a cinema in a theater or anywhere, right, so that particular scene will be available to me with with length and breadth. Okay, and then that is in the form of rectangle or in the form of square, that will be a visible for me, right? It is not visible for me in the form of cylinder or sphere or ellipse. So, Athara, it is not visible for me. It is visible for me in the form of a square or a rectangle. Fine, right? So that is what we call it as local coordinates. Local coordinates, right? In the bare eyes, right? What are the things that we see, right? Those are local coordinates. Okay, right? Whatever objects that I see, right? That objects coordinates are local coordinates. Okay, right? Yes, you people. Yes, you people, now you may be visualizing your mobile, or you may be visualizing your laptop. Okay, right? So with the bare eyes, you are right, you are visualizing your laptop or mobile, right? So the coordinates of that laptop or the coordinates of that mobile are local coordinates. Okay, right? So now consider someone behind you, right, will take a photograph of you sitting with your laptop, right? And you will take the printout. That printout may be a passport size printout, or it may be 4 by 6 printout. When it takes and comes to you, right? So whatever you are seeing, right, with the bare eyes, right, in the laptop, when you see that in the photograph, you see all the things will be minimized in the size, right? So minimized in the size means those also has x and y coordinates for the objects. ಕರೆಕ್ಟಾ? ಇಲ್ಲಿ ರೆಡ್ ಕಲರ್ ಅಲ್ಲಿ ಕ್ವಶನ್ ಅಂತ ಬರ್ತಿದ್ದೀನಿ, ರೈಟ್? ಸೊ ನೀವು ಒರಿಜಿನಲ್ ಆಗಿ ನೀವು ನೋಡೋದಕ್ಕೂ ಹಿಂದೆಗಡೆ ಯಾರೋ ಫೋಟೋ they will take a photo and they will come to you with that copy, and when you see that, right, so definitely there will be a difference, right? Because whatever you are seeing, right, your viewing window is large, whatever that particular camera's viewing window is small, right? Obviously ಚಿಕ್ಕ ಕಾಣಿಸುತ್ತೆ ಅದರಲ್ಲಿ, right? But that also has coordinates, x y coordinates or something coordinates, right? So that coordinate which is available in the device is called as device coordinates. Through the device is called as device coordinates, right? ಅಂದ್ರೆ ನೀವು ಕ್ಯಾಮ್ರಾದಲ್ಲಿ ಏನ್ ಕ್ಯಾಪ್ಚರ್ ಮಾಡ್ತಿರಲ್ಲ, ರೈಟ್, ಕ್ಯಾಪ್ಚರ್ ಮಾಡಿ ತಗೊಂಡ್ಬರ್ತಿರಲ್ಲ, ರೈಟ್? ಸೊ ಅದ್ರದ್ದು ಕೋಆರ್ಡಿನೇಟ್ಸ್, ಆ ಆಬ್ಜೆಕ್ಟ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್, ವಿ ಕಾಲ್ ದಟ್ ಆಸ್ ಡಿವೈಸ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್, right? And the coordinates the coordinates of the same object that you are seeing with your bare eyes, those coordinates are called as local coordinates. Okay, right? So now here what is what is my discussion is, right? My discussion is, right, how do you convert that local coordinates into device coordinates? ಹೆಂಗೆ ನಿಮ್ಮ ಕ್ಯಾಮ್ರಾ that will convert your local coordinates into device coordinates ಅಂತ. Fine, right? So that is, in general, several different Cartesian coordinate frames are used to process and constructing a display of constructing and displaying a scene, right? See, whatever you think, right, you will just take a camera and you will just click the button and you will get the photo of it, right? So within a fraction of a second you will get the photocopy of the scene, right? But actually what all the process that happens inside the camera, right, so which will give us that particular scene, right, so is very interesting. Okay, that is what they say, right? So several different Cartesian reference frames or reference frames are used to process and constructing a display scene. Okay, right? So now first what happens is, right, right, we will define the shapes of individual objects such as tree or furniture within separate reference frame for the object, and these reference frame are called modeling coordinates or local coordinates, right? So that means, for example, let us consider that right in front of you there is a bicycle. Okay, right? So now you will take the image of the bicycle. Fine, right? See, whenever you take the image of the bicycle, that bicycle contains various parts. For example, that contains handles, okay, right? That contains a seat, right? That contains that contains a straight rod, right, in the front. Fine, that contains a carrier in the back, right? That contains the wheels, okay? That contains spokes, okay, which is straight in nature, right? So these are all the different parts of a scene. Okay, right. So now what your camera does is, right, see all the parts that is present in your screen, right, so will not be very clearly available, cannot be clearly drawn with the taking the same coordinate plane. See what coordinate plane till we know till now is, yes, 1 minute, right. See what coordinate plane that we know till now is Cartesian coordinate plane. Okay, right, that is the only coordinate plane that we know till now. Fine, right. So that is for example, right, ನೀವೇನೇ ಒಂದು ಡ್ರಾ ಮಾಡಬೇಕು ಅಂದ್ರು, right, what you will use, you will definitely use graph. Okay, right. So in your graph, what are the coordinates that you have, right, which you know, right, in your graph what are the coordinates that you have is you have x, you have only x axis and y axis, right. So maximum, right, you may get z axis. Okay, if you consider your 3D image, right, so you come across with your x-axis, you come across with your y-axis, right, so you come across with your z-axis, right. So any object till now you have represented in this particular coordinate frame, right, coordinate system. Okay, right, which coordinate system you have you people know till now, right, it is xy coordinate system, right, or I call this coordinate system as Cartesian coordinate system. Okay, right, see this Cartesian coordinate system is well suited for drawing a particular type of images. Okay, this Cartesian coordinate system is not suitable for drawing all the types of images, right. So that means, right, this Cartesian system is well suited for drawing the images, right, so which has some straight line in nature. Okay, okay, right. So that means, right, coming to your bicycle which you are trying to capture in your mobile, right, so you have handle which is almost straight in nature, you have that bar in the front which is almost straight in nature, you have carrier towards back side, right, which is rectangle in nature, that means that also has a straight line structure. Fine, right. See, drawing all those things, right, will be very easy with this Cartesian coordinate system which has x, y, and z axis, because here everything you will deal with height and breadth. Correct, right? So in Cartesian coordinate system, what you know till now, right? So you deal everything with height and breadth, right? So which are all the things that becomes easy for you to draw with respect to bicycle, right? So your straight bar which is there, right? It has length and breadth. Okay, that you will draw, right? You have handle. That handle also has length and breadth. Okay, that you will draw. You have a carrier beside that is also a rectangle in nature or square in nature, which is that is where the size of that will be determined by length and breadth. Okay, that also you will draw using this Cartesian coordinate system. Okay, right. Now coming to other parts. Okay, fine, right. So now the main important part is your wheel. Okay, right. So your wheel is circular in nature. Okay, right. So your wheel is circular in nature, right? And drawing your wheel using Cartesian coordinate is very difficult. Okay, circle na draw ಮಾಡೋದು Cartesian coordinate system ಅಲ್ಲಿ XYZ axis ಇರೋ system, XYZ axis ಇರೋ system ಅಂದ್ರೆ those are all lengths. Fine, right? So in this particular that is coordinate system, that is Cartesian coordinate system, right? So it is suitable for drawing only pictures where the complete size of the pictures are determined by length and breadth. Okay, right. So whenever my object size is not determined by length and breadth. Okay, right, whenever it is not determined by length and breadth, for example take circle, right, you have wheel in your bicycle, right, I cannot draw that wheel in my wheel which is there in your bicycle, right, very easily or very comfortably using Cartesian coordinate system. Okay, right, that is why I was telling you from the starting class, right. So see this what OpenGL, what library that you are using, right. So that particular OpenGL library is is the library that is used for drawing anything using Cartesian coordinate systems. Okay, ಅಂದ್ರೆ x y z axis ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಇರೋ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಮಾತ್ರ ನಾವು ಆಬ್ಜೆಕ್ಟ್ಸ್ ನ ಬರಿತಾ ಹೋಗ್ತೀವಿ, right? So I said to you, right, you have primitives for all the objects, drawing all the objects except the one which involves curves. ಓಕೆ, ನಮ್ಗೆ ಎಲ್ಲೆಲ್ಲಿ ಕರ್ವ್ ಬರುತ್ತೋ ಅಲ್ಲಿ ದಿಸ್ ಕಾರ್ಟಿಷಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ರೈಟ್ ಫೇಲ್ಸ್ ಟು ಗಿವ್ ದ ಎಕ್ಸಾಕ್ಟ್ ಪಿಕ್ಚರ್. It will give an arbitrary picture. Okay, right, I won't deny with that, it will give you the arbitrary picture, right? But wherever you need this exact image, right, so there for the images that I have that where this where the size of the image is not represented by its length and breadth, right, there this Cartesian coordinate system fails. Okay, right? So in your camera, right, or in any of the device which has the capability of capturing, okay, camera no mobile aliro camera, so okay, right, or anything, right, which has the capability of capturing, right, so within it, right, so it has the capability of designing, right, not only this Cartesian coordinate system, right, it has the capability of designing, right, so designing the objects in various coordinate systems, right, various coordinate systems in the sense, right, so Cartesian coordinate system is one. Okay, right, so Cartesian coordinate system is one type, right, so another type is spherical coordinate system, right, another one is cylindrical coordinate system. Okay, cylindrical coordinate system. These are the different coordinate systems that are available for us. Okay, what we have learned is we have learned only this Cartesian coordinate system which has x, y, and z axis. Okay, right, where everything will be dealt with x, y, and z axis. Now, whenever I need to draw a circle, okay, right, so my camera which is there, right, will not use this Cartesian coordinate system. Okay, right, it uses sorry, this is cylindrical, right? So whenever I have circle to be drawn, right, so this uses this spherical coordinate system. Okay, all these coordinate systems will be present in with the drivers, okay, of our camera. Fine, right? So what this drivers contains, this drivers contains, right, so designing with Cartesian coordinate system, designing our some parts with spherical coordinate system, designing some parts with cylindrical coordinate system, right, others, there are other different coordinate system. Just for our reference I have named these things, right? Whenever I need to draw the circle, this circle, okay, right, will be drawn using this spherical coordinate system. Okay, right, so how here everything will be represented with x, y, and z. Okay, right, in my spherical coordinate system, right, everything is represented with radius. Okay, x, right, so what x represents, x represents which is the central point, okay, from where I need to draw, that is x, right, and radius r, okay, right, and it is phi. Okay, what this phi represents, this phi represents with what height I need to draw, under this distance. Okay, this is my spherical coordinate system coordinates. Okay, how you have in your Cartesian coordinate system X, Y, and Z, where you can design anything which has any object which has the property of straight lines, right? On the same lines, right? So curves. Okay, what I have, right? I can design that with the spherical coordinate system very easily with spherical coordinate system, right? Because its coordinates are x. X means, right, which is the center point. Its coordinates is radius. Okay, what is the radius with which I need to draw, and its coordinate is phi, which represents with what height I need to draw. This is very easy compared to this. For drawing my circle, obviously I need a center point, I need the radius. Okay, right? So this is what we know for drawing any circular objects, right? What are the things that we want, right? So we want radius, we want from what position I need to draw, right? So if that particular thing itself is available as the coordinates in any of the coordinate system, definitely I can use that and it becomes easy for me to draw, right? So that is what is the disadvantage of Cartesian coordinate system, which you people are using till now. All your graph sheets that you are using, say the semi-log, all sheets, right? Those are Cartesian coordinates. ಎಲ್ಲೆಲ್ಲಿ ನಾನು x, y, z use ಮಾಡ್ತೀನಿ, right? All these things are Cartesian coordinate system, which suits only for the drawings which has straight lines as its attributes. Okay, right? ನನ್ನ ಕ್ಯಾಮ್ರಾ ಡ್ರೈವರ್ಸ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ಎಲ್ಲಾರು ಸಿಸ್ಟಮ್ಸ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ನನ್ನ ಕ್ಯಾಮ್ರಾ ಏನ್ ಮಾಡುತ್ತೆ, ಒಂದು ಪಿಕ್ಚರ್ ತೆಗಿತಾ ಇದ್ದಂಗೆ, ರೈಟ್? ಸೊ ಮೈ ಕ್ಯಾಮ್ರಾ ವಿಲ್ ಡ್ರಾ ಆಲ್ ದ ಥಿಂಗ್ಸ್ ವಿಚ್ ಆರ್ ರಿಲೇಟೆಡ್ ಟು ಸ್ಟ್ರೈಟ್ ಲೈನ್ಸ್, ರೈಟ್? ಅದೇ ನಾನು ಹೇಳಿದ್ನಲ್ಲ, ರೈಟ್? ಹ್ಯಾಂಡಲ್ಸು, ಓಕೆ, ರೈಟ್? ಅದಕ್ಕೆ ಸಪೋರ್ಟಿಂಗ್ ಸ್ಟ್ರೈಟ್ ಬಾರ್ಸು, ಓಕೆ, ಅಲ್ಲೊಂದು ಹಾರಿಜಾಂಟಲ್ ಬಾರ್ ಇರುತ್ತೆ, ಅದು ಹಿಂದೆಗಡೆ ಕ್ಯಾರಿಯರ್, ರೈಟ್? ಸೊ ಅದಕ್ಕೆ ಸಪೋರ್ಟಿಂಗ್ ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ ಎರಡು ವರ್ಟಿಕಲ್ ಸ್ಟೀಲ್ ರಿಮ್ಸ್, ಅದು, ಆಮೇಲಿಂದ ನಿಮ್ಮ ವೀಲ್ ಅಲ್ಲಿರೋ ಸ್ಪೋಕ್ಸು, ರೈಟ್? ಸೊ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಸೈನ್ಡ್ ಇನ್ಸೈಡ್ ಯುವರ್ camera with this Cartesian coordinate system. Okay, right? Now when it comes to any curve pattern, right? So curve pattern ಅಂದ್ರೆ ವೀಲ್ಸ್, ಆಮೇಲೆ ನಿಮ್ದು ಸೀಟ್ ಇರುತ್ತಲ್ಲ, ರೈಟ್? ನಿಮ್ ಸೀಟು ಅಷ್ಟೇ, ಇಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಸ್ಕ್ವಯರ್ ರೆಕ್ಟಾಂಗಲ್ ಇರೋದಿಲ್ಲ, ಅದು ಕರ್ವ್ ಇರುತ್ತೆ, right? That all those things will be designed using this spherical coordinate system within your camera. And if there is any cylindrical structure, a cylinder, hale in older cycles, right, you may have find that cylindrical structure, ನಮ್ಗೆ ಆ ಸಿಲಿಂಡರ್ ತರ ಒಂದಿರೋದು ಬ್ಯಾಕ್ ಸೈಡ್ ಟೈರ್ಗೆ, ರೈಟ್? ಸೊ that was the one which was providing the light for us. Okay, right? ಹಳೆ ಹೀರೋ ಸೈಕಲ್ಸ್, ಇಫ್ ಯು ರಿಮೆಂಬರ್, ಇಟ್ ವಿಲ್ ಬಿ ದೇರ್, ಅದು ಸಿಲಿಂಡರ್ ತರ ಇರೋದು, ರೈಟ್? ಸೊ ದಟ್ ಪಾರ್ಟ್ ವಿಲ್ ಬಿ ಡಿಸೈನ್ಡ್ ಬೈ ಸಿಲಿಂಡ್ರಿಕಲ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್. Okay, right? Like this, within my camera, right? My camera uses all these different coordinate system for designing different objects. Okay, right? Now see here, I'm explaining you, right, how your camera works. It is a very important thing. In camera ದಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಡ್ರೈವರ್ ಏನೋ ಒಂದು ಮಿಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ಸ್ಗಳು ನಿಮಗೆ ಕಾಣೋದಿಲ್ಲ, ರೈಟ್? ಈ ಒಂದು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಿಮ್ ಡ್ರೈವರ್ ಸರಿಯಾಗಿ ನಿಮ್ಮ ಕ್ಯಾಮ್ರಾ ಒಳಗೆ, ರೈಟ್, ಡ್ರೈವರ್ ಸರಿಯಾಗಿ ಇನ್ಸ್ಟಾಲ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವ್ದೋ ಸ್ಪೆರಿಕಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಡ್ರೈವರು ಅಥವಾ ಸಿಲಿಂಡ್ರಿಕಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಡ್ರೈವರು ಯಾವ್ದೋ ಒಂದು ಕರಪ್ಟ್ ಆಗಿದೆ ಅಂದ್ರೆ, ರೈಟ್, ಸೊ ಯು ವಿಲ್ ವಿಜುವಲೈಸ್. ಓಕೆ, ರೈಟ್? ಸೊ ನಿಮ್ಮ ಇದು ಸರ್ಕಲ್ ಶೇಪು ಕರೆಕ್ಟ್ ಆಗಿ ಬರೋದೇ ಇಲ್ಲ, ಒಂಥರ ಹ್ಯಾಪಾಜಾರ್ಡ್ ಆಗಿ ಬರುತ್ತೆ, ರೈಟ್? ಸೊ ಕಾರ್ಟಿಷಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಏನೋ ಕರಪ್ಟ್ ಆಗ್ಬಿಟ್ಟಿದೆ ಅಂದ್ರೆ ಸ್ಟ್ರೈಟ್ ಲೈನ್ಸ್ಗಳು ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗಿ ಬರೋದಿಲ್ಲ, ಒಂಥರ ಹ್ಯಾಪಾಜಾರ್ಡ್ ಆಗಿ ಬರ್ತಾ ಇರುತ್ತೆ, right? So all those things are because of this drivers. Okay, it contains your camera contains the drivers which contains all the softwares for this inside this, right? Spherical coordinate system ಅಲ್ಲಿ ಡ್ರಾ ಮಾಡೋಕ್ಕೆ, Cartesian coordinate system ಅಲ್ಲಿ ಡ್ರಾ ಮಾಡೋದಕ್ಕೆ, cylindrical coordinate system ಅಲ್ಲಿ ಡ್ರಾ ಮಾಡೋದಕ್ಕೆ, ಈ ತರ, right? So now first what happens is, right, so individual shapes of the individual objects. Okay, ನಾನು ಸೀನ್ ಬೈಸಿಕಲ್ ಇದೆ, ಅದರಲ್ಲಿ ಇಂಡಿವಿಜುವಲ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಅಂದ್ರೆ, ರೈಟ್? ಸೊ ಹ್ಯಾಂಡಲ್ಲು, ಬ್ರೇಕು ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಅಂತಾನೆ, ಬ್ರೇಕ್ಸು, ವೀಲ್ಸು, ರೈಟ್? ಸೀಟು, ಹಿಂದೆಗಡೆ ಸೀಟ್, ಬ್ಯಾಕ್ ಸೈಡ್ ಸೀಟ್, ರೈಟ್? ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆರ್ ಇಂಡಿವಿಜುವಲ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ವಿಚ್ ಆಲ್ ದೀಸ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ವಿಲ್ ಬಿ ಡ್ರಾನ್ ಇನ್ ದ ಸಪರೇಟ್ ರೆಫರೆನ್ಸ್ ಫ್ರೇಮ್. ಅಂದ್ರೆ those objects, right, which is comfortable with the particular reference frame, it will be drawn, right? ಸೊ ನಾನು ಹೇಗೆ ಹೇಳಿದೆ, ಸೊ ಈಗ ವೀಲ್ ಆಗ್ಲಿ ಅಥವಾ ನಿಮ್ ಸೀಟ್ ಆಗ್ಲಿ, ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಡ್ರಾನ್ ಯೂಸಿಂಗ್ ಸ್ಪೆರಿಕಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್. Other things which are comfortable with Cartesian coordinate system, which involves a straight lines, those are drawn with your Cartesian coordinate systems, right? So, and these reference frames are called modeling coordinates, or we say that as local coordinates or master coordinates, right? Each and individual objects that are drawn in their individual or that is in their own reference systems, right? So those reference frame and those scenes or those objects are called as local coordinates or modeling coordinates or master coordinates. Okay, is it clear what are local coordinates? Fine, right? So please see what you are this time what they have made is MCQs. Fine, right? But coming to a final exam, it will be of a theoretical type where you need to write it down, right? So so what I will be doing is, right, so this should, it should finally help your final exam, your final examination. Fine. So I will be taking the concepts from your notes itself, and I will be giving that as MCQs. Okay, right? That means you should be. That means you will be ready for ready. You will be ready if they give you to write it in theory part or in MCQs part. Okay, either one of the example is this, right? So I will give this question. I will give the question as this, right? So we define the shapes of individual objects, okay, within a separate reference frames called as, okay, right, modeling coordinates. Other coordinates you will see it later. Those coordinates I will give you in different options, right? You need to analyze which is the correct answer. See, if you have studied the things which are present in the notes in detail, you will come to know that. Else you need to play, and you need to just give the answers randomly. Okay, right? So this is called as local coordinates, where each and individual objects of my screen are drawn in their respective coordinate systems, right? After drawing all those things in the respective coordinate systems, right? So what is the coordinate system that our eye will recognize? Or finally finally we want the picture in that is photo which is in Cartesian coordinate only, which has x and y only, right? 4 by 6 ಅಂತೀವಿ, 16 by 8 ಅಂತೀವಿ, ಅಂದ್ರೆ length ಮತ್ತೆ breadth. That means finally we want the picture in that only, in Cartesian coordinates ಅಲ್ಲೇ ಬೇಕಾ ನಮಗೆ, right? So now what we will do, the second step is, right, we will bring all the objects that we have drawn in all the different coordinate system to a single coordinate system, that is my what is that Cartesian coordinate system called as world coordinates. Okay, right? That is the second step. What is the second step? Once the individual objects have been specified in their own respective coordinate system, we construct a model of a scene, right? That is model under a scene by placing all the objects into appropriate locations within the scene reference frame called world coordinates. Which is the scene reference frame? Which is my reference frame? Photo is my reference frame. My photo, what is that? What is the coordinate? What is the coordinate system of my photo? It is Cartesian coordinate system. That is x y ಇದೆ, x y ಇರುತ್ತೆ ನನ್ನ photo. ನಾನು ಯಾವುದು I don't have any photo which is circle in shape. I don't have any photo which is cylindrical in shape. Okay, ಅದನ್ನೆಲ್ಲ animation ಮಾಡಿ ವಿಡಿಯೋದಲ್ಲಿ ತೋರಿಸ್ತಾರೆ. Okay, but ಫೋಟೋದಲ್ಲಿ ಯಾವುದು ಬರಲ್ಲ. Correct, right? So that means finally what are the things that I have designed, okay, in individual reference frame, right? I need to bring all those pictures into a what is that into within a scene reference, okay, right? That scene reference is nothing but my scene reference is photo frame, right? And I will bring all those things into Cartesian coordinate frames. That particular coordinates are called as world coordinates. Okay, right? Once I bring everything into everything into a particular scene reference frame where, in which I need to display, ಅಂದ್ರೆ ನನ್ನ ಫೋಟೋ ಫ್ರೇಮ್ ಒಳಗೆ ಎಲ್ಲದನ್ನು ಆ ಫೋಟೋ ಫ್ರೇಮ್ ಇರುತ್ತಲ್ಲಪ್ಪ, what ಆ ಫ್ರೇಮ್ ಒಳಗೆ when I bring all the objects, right? So next thing ಏನ್ ಮಾಡ್ತೀವಿ, what are the other things that I can do? Right? What are the other things that a photographer may do? Keeping those things. ಈಗ Fine. You may have seen the photos, right? ಇಲ್ಲಿ ಹಿಂಗ್ ಕೆಳಗಡೆಯಿಂದ ಹಿಂಗ್ ಮೇಲ್ಗಡೆ ನೋಡ್ತಿರೋ ಹಂಗೆ ವ್ಯೂ, ಅಥವಾ ಮೇಲ್ಗಡೆಯಿಂದ ಹಿಂಗ್ ಕೆಳಗಡೆ ನೋಡ್ತಿರೋ ತರ ವ್ಯೂ, ಅಥವಾ ರೈಟ್ ಸೊ ಎಲ್ಲೋ ಹಿಂಗೆ ಸೈಡ್ ಅಲ್ಲಿ ನೋಡ್ತಿರೋ ವ್ಯೂ. ಓಕೆ, ಆ ತರ ಚೇಂಜಸ್ ಹಿ ಕ್ಯಾನ್ ಡೂ. ಕರೆಕ್ಟಾ? ದಟ್ ಮೀನ್ಸ್ ಹಿ ಕ್ಯಾನ್ ಚೇಂಜ್ ದ ಪೊಸಿಷನ್ಸ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್. ಫೈನ್, ರೈಟ್? ಅಂದ್ರೆ ವ್ಯೂವಿಂಗ್ ನಾನು ಚೇಂಜ್ ಮಾಡ್ಬೋದು. ಕರೆಕ್ಟ್ ಅನ್ರಿ? ಒಂದು ಫೋಟೋ ಬಂದ್ಮೇಲೆ ರೈಟ್ ಅದನ್ನ ನಾನು ಅದಕ್ಕೆ ಡಿಫ್ರೆಂಟ್ ಸ್ಟೈಲ್ಸ್ ಮತ್ತೆ ಡಿಫ್ರೆಂಟ್ ವೇರಿಯೇಷನ್ಸ್ ನಾವು ಕೊಡ್ಬೋದು. ಕರೆಕ್ಟಾ? ರೈಟ್? ಒಂಥರ ಏನೋ ಹಿಂಗೆ ಕೆಳಗಡೆಯಿಂದ ಹಿಂಗ್ ನೋಡ್ತಾ ಇರೋ ಹಂಗೆ ಫೋಟೋನ, ಅಥವಾ ಹಿಂಗ್ ಮೇಲ್ಗಡೆಯಿಂದ ಹಿಂಗೆ ನೋಡ್ತಾ ಇರೋ ಹಂಗೆ ಫೋಟೋನ. Right? That means, right, after everything, after all the objects coming to the required frame for us, right? So now next ಏನ್ ಮಾಡ್ಬೋದು, ಅದ್ರ ಒಳಗಡೆ ನಾವು ಆಲ್ಟರೇಷನ್ಸ್ ಮಾಡ್ಬೋದು. Right? That means I can change the viewing and projection of the objects. ಕರೆಕ್ಟಾ? ರೈಟ್? ನಾನು ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡ್ಬೋದು ಆಬ್ಜೆಕ್ಟ್ ನ. ರೈಟ್? ಹೆಂಗೆ? ರೈಟ್? ಸೊ ಏನೋ ಹಿಂಗ್ ಸೈಡ್ ಅಲ್ಲಿ ನಿಂತಿರೋ ಹಂಗೆ. ಓಕೆ, ರೈಟ್? ಸೊ ಇನ್ನೆಲ್ಲೋ ಹಿಂಗೆ ಬಕ್ಕೊಂಡು ನಿಂತಿರೋ ಹಂಗೆ. ಕರೆಕ್ಟಾ? ರೈಟ್? ಸೊ ಅಥವಾ ಮನುಷ್ಯ ಹಿಂಗ್ ಸ್ಟ್ರೈಟ್ ಆಗಿ ನಿಂತಿರೋ ಹಿಂಗ್ ಇನ್ಕ್ಲೈನ್ ಮಾಡ್ಬೋದು. Right? Those are all the projections that I can do. And then I can also specify the viewing. Specify the viewing as a right. I can make that photo such that right that photo is visible. That photo is that particular scene is visible from a far distance. ಅಥವಾ ಫ್ರಮ್ ದ ಟಾಪ್ ಕಾಣಿಸ್ತಾ ಇರೋ ಹಂಗೆ ಆಬ್ಜೆಕ್ಟ್ಸ್, ಅಥವಾ ಸೈಡ್ ವೇಸ್ ಅಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇರೋ ಹಂಗೆ. ರೈಟ್? ಸೊ ದಟ್ ಮೀನ್ಸ್ ಐ ಕ್ಯಾನ್ ಚೇಂಜ್ ದ ವ್ಯೂವಿಂಗ್ ಅಂಡ್ ಪ್ರೊಜೆಕ್ಷನ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ಸ್ ವಿತ್ ಇನ್ ದ ಫೋಟೋ. That is the third step. Okay, right? So that is what they say here, third step, right? This step involves transformation of individual modeling coordinate frame to specified position and orientation, and orienting them within the coordinate frame. Right? So transformation of individual modeling frame ಅಂತ ಅದೇ. ರೈಟ್? ಈಗ ಒಂದು ಮನುಷ್ಯನ ನಾನು ಇಡ್ತೀನಿ ಫೋಟೋ ಫ್ರೇಮ್ ಒಳಗೆ. ಓಕೆ, ರೈಟ್? ಅಥವಾ ಒಂದು ವೀಲ್ ನ ಇಡ್ತೀನಿ. ಆ ವೀಲ್ ನ ಇಟ್ಬಿಟ್ಟು ರೈಟ್ ಸ್ವಲ್ಪ ಆ ವೀಲ್ ನ ಹಿಂಗ್ ರೊಟೇಟ್ ಮಾಡಿದಿರೋ ಹಿಂಗೆ ರೊಟೇಟ್ ಮಾಡೋಂಗೆ. ಓಕೆ, ಈ ಮನುಷ್ಯ ನಿಂತಿರೋನು ಸ್ವಲ್ಪ ಹಿಂಗ್ ಬೆಂಡ್ ಆಗಿರೋಂಗೆ, ಸ್ವಲ್ಪ ಹಿಂಗ್ ಮೂವ್ ಆಗಿರೋಂಗೆ. ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ಸ್ ವಿಚ್ ಯು ವಿಲ್ ಸಿ ಇನ್ ದ ಸೆಕೆಂಡ್ ಮಾಡ್ಯೂಲ್, ವಿಚ್ ಇಸ್ ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. ರೈಟ್? ದಟ್ ಮೀನ್ಸ್ ವ್ಯೂವಿಂಗ್ ಮತ್ತೆ ಪ್ರೊಜೆಕ್ಷನ್ಸ್ ನಾವು ಚೇಂಜ್ ಮಾಡ್ತೀವಿ. ರೈಟ್? ಅಂಡ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಥಿಂಗ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ವ್ಯೂವಿಂಗ್ ಪೈಪ್ಲೈನ್. ಓಕೆ, ರೈಟ್? ಸೊ ಅಂಡ್ ದೆನ್ ಫೈನಲಿ ವಾಟ್ ವಿ ವಿಲ್ ಬಿ ಡೂಯಿಂಗ್ is fine, right? So finally what we will be doing is, right, we will bring the final scene. Okay, final scene andre enu, right? So what all the things that we have done, right? So till now what all the things that we have done is, right, so we have done modeling coordinates. Okay, modeling coordinates andre in the scene, if I'm taking the same example, if the object is bicycle or something, right? So what I have done, right, so I have divided that bicycle into different parts, and I have drawn the different parts using different coordinate reference frames. That is what they have done here. Nodi, ಇಲ್ಲಿ ಸ್ಕ್ವೇರ್ ಇದೆ, ಅದನ್ನ XYZ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಮಾಡಿದ್ದಾರೆ. ಇಲ್ಲೊಂದು ಸಿಲಿಂಡರ್ ಇದೆ, ಅದನ್ನ ಸಿಲಿಂಡ್ರಿಕಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್. ನಮ್ಗೆ ಯಾವ್ಯಾವ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ್ಯಾವ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಬೇಕೋ ಆ ತರ ಎಲ್ಲ ಡಿಸೈನ್ ಮಾಡಿದ್ವಿ. ರೈಟ್? So then what we did, right, we brought all the objects that are in different reference frame to a single reference frame. Right? So ನೋಡಿ, ಈ ಸಿಲಿಂಡರ್ ನ ಮತ್ತೆ ಇದು ಏನಿದೆ ಸ್ಕ್ವೇರ್ ಅಥವಾ ಏನ್ ಕರೀತೆ ಟ್ಯೂಬ್ ನ, right, we have brought that into single reference frame. That we will call it as world coordinates. Okay, individual objects na ನಾವು ಬರೆಯೋದನ್ನ we call those things as local coordinates or modeling coordinates or master coordinates. Right? When we bring all those objects which we have written in different coordinate system to a single coordinate system, that particular coordinate system is called as world coordinates. ಎಲ್ಲದನ್ನು ಅಡ್ಜಸ್ಟ್ ಮಾಡಿ ಒಂದೇ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಒಳಗೆ ತರ್ತೀವಿ. ರೈಟ್? ಸೊ ಇನ್ ಅವರ್ ಕೇಸ್ ಇಟ್ ಈಸ್ ಕಾರ್ಟಿಷಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಒಳಗೆ ಎಲ್ಲಾ ಆಬ್ಜೆಕ್ಟ್ಸ್ ತರೋದು. ಬಿಕಾಸ್ ವಾಟ್ ಅವರ್ ಫೋಟೋ has, right, my photo is a Cartesian coordinate system, x to y axis ಇದೆ ಅದಕ್ಕೆ. Right? So then we will give some viewing, projections, ಯಾವ ತರ ಬೇಕೋ ಆ ತರ ಅದನ್ನ ಮಾಡ್ತೀವಿ. ಅದನ್ನ we will change our photo, our scene. Right? Once we are done with all the alterations for our photo, finally what we will do is, right, so we will convert that particular scene or that particular photo image into normalized coordinates. Okay, normalized coordinates andre na ಏನು normalized coordinates andre, right, so I bring all the dimensions of my actual object, right, so between 0 to 1. 0 is minimum, 1 is maximum, ಅಥವಾ -1 to 1 ಒಳಗೆ ತಂದ್ಬಿಡ್ತೀನಿ ಎಲ್ಲ ಆಬ್ಜೆಕ್ಟ್ನು ನಾನು ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೆಂತ್ ಬ್ರೆಡ್ಗೆ ತಂದ್ಬಿಡ್ತೀನಿ, ರೈಟ್. ದಟ್ ಈಸ್ ಮೈ ನಾರ್ಮಲೈಸ್ಡ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್. ಓಕೆ, ನಾರ್ಮಲೈಸ್ಡ್ ಅಂದ್ರೆ ಏನು? ದಟ್ ಈಸ್ ವಾಟ್, ರೈಟ್. ಸೊ ಅದನ್ನ ಐ ಆಮ್ ಬ್ರಿಂಗಿಂಗ್ ಎವ್ರಿಥಿಂಗ್, ಐ ಆಮ್ ಬ್ರಿಂಗಿಂಗ್ ಕಂಪ್ಲೀಟ್ ಸೀನ್, ರೈಟ್. ಸೊ that is, I am bringing all the objects in my scene, right, which have been finalized to normalized coordinates. Andre between 0 to 1, between 0 to 1 or between -1 to 1 ಎಲ್ಲಾದ್ರದ್ದು ಸೈಜಸ್ ನ ತಂದ್ಬಿಡ್ತೀನಿ, ರೈಟ್. ಏನಕ್ಕೆ ತರ್ತೀನಿ ಅಂತಂದ್ರೆ, ರೈಟ್, ಸೊ ಫೈನಲಿ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಟು ದ ಮಾನಿಟರ್ಸ್. Okay, whenever it has to move to the monitors, okay, right. For example, consider my monitor or my display is 4/6 ಅನ್ಕೊಳ್ಳಿ. Okay, right. So ನಾನು ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೀನಿ, fine. So I have brought, right, I have brought all the objects, right. So right, I have brought all the objects, right, to normalized coordinate size. Okay, to normalized coordinate size andre, right, so maximum 1, okay, ಇದು maximum 1. ಓಕೆ, ಅಷ್ಟರೊಳಗೆ ನಾನು ಎಲ್ಲದನ್ನು ಐ ಹ್ಯಾವ್ ಕನ್ವರ್ಟೆಡ್ ದ ಸೈಜ್. ಓಕೆ, ಈಗ ಲೆಂತ್ 4 ಅಂತಿದ್ರೆ ಅದನ್ನ 0 to 1 ಒಳಗೆ ತಂದ್ಬಿಡ್ತೀನಿ. ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ವಿಲ್ ಬ್ರಿಂಗ್ ದಟ್ ಟು 0.4, ರೈಟ್. ಸೊ ಹೈಟ್ 0.6 ಅಂತಿದ್ರೆ, ರೈಟ್, 0 to 1 ಒಳಗೆ ನಾನು ತಂದ್ಬಿಡ್ತೀನಿ, ಅಂದ್ರೆ 0.6 ತಂದ್ಬಿಡ್ತೀನಿ. Okay, right. ಅದೇ ತರ I will bring the size of all the objects that are ready to be displayed to normalized coordinates, ಅಂದ್ರೆ between 0 to 1. Okay, that is between 0 to 1 or between -1 to +1. Right? So now ಇವಾಗ ಆ ತರ ಎಲ್ಲ ಮಾಡಿದೀನಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ರೈಟ್, ಸೊ I have this particular ಸ್ಕ್ವೇರ್ ರೆಕ್ಟಾಂಗಲ್ ಅನ್ಕೊಳ್ಳಿ, ರೈಟ್. ಸೊ ರೆಕ್ಟಾಂಗಲ್ ನಾನು ಏನ್ ಮಾಡಿದೀನಿ ಇಲ್ಲಿ, ರೈಟ್. ಸೊ ವಿಡ್ತ್ ಏನಿತ್ತು, ಆ ವಿಡ್ತ್ ನಾನು 0.4 ತಂದ್ಬಿಟ್ಟಿದೀನಿ. ಓಕೆ, ಹೈಟ್ ಏನಿತ್ತು, ಓಕೆ, ಅದನ್ನ ನಾನು ಏನ್ ಮಾಡಿದೀನಿ 0.6 ತಂದ್ಬಿಟ್ಟಿದೀನಿ. ಓಕೆ, ನಾರ್ಮಲೈಸ್ಡ್ 0 to 1 ಒಳಗೆ ತರಬೇಕಲ್ವಾ ಎಲ್ಲದನ್ನು. ಸೊ ಈ ವಿಡ್ತ್ ಏನಿತ್ತು ಅದನ್ನ 0.4 ತಂದ್ಬಿಟ್ಟಿದೀನಿ, ಹೈಟ್ ಏನಿತ್ತು ಅದನ್ನ 0.6 ತಂದ್ಬಿಟ್ಟಿದೀನಿ, right. So next what I need to do is, right, I need to convert this, okay, right, to the required display coordinates. Okay, right, I need to convert this to the required display coordinate. What is this display coordinate says, right? ಈಗ display coordinate says, right, so display coordinates ಅಂದ್ರೆ ನಾನು ಡಿಸ್ಪ್ಲೇ ಆಗಬೇಕಾಗಿರೋ ಇಮೇಜಿನ ಕೋಆರ್ಡಿನೇಟ್ಸ್. ನಾನು ಡಿಸ್ಪ್ಲೇ ಆಗಬೇಕಾಗಿರೋ ಇಮೇಜಿನ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಅಂದ್ರೆ, ರೈಟ್, ಸೊ ಯುವರ್ ಫೋಟೋ, ರೈಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕನ್ಸಿಡರ್ ಯುವರ್ ಫೋಟೋ. ಓಕೆ, ರೈಟ್, ಯುವರ್ ಫೋಟೋ ಈಸ್ ಆಫ್ breadth 4 inches and height of 6 inches, ಅಂದ್ರೆ 4/6 ಫೋಟೋ ತರಬೇಕು, ರೈಟ್. ಸೊ ಇನ್ನೊಂದು ಡಿಸ್ಪ್ಲೇ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಇದೆ, ರೈಟ್. ಸೊ ವೇರ್ ಯು ಹ್ಯಾವ್ ಅ ಫೋಟೋ ಫ್ರೇಮ್, ರೈಟ್, ವೇರ್ ದ ಲೆಂತ್ is 8, right, and the height is 16. Okay, na, right? These are the different display coordinates. These are the different display images that I have, right. One photo I have which is of 4/6, another photo I have which is of 8/16. ಅಲ್ಲಿಗೆ ನನ್ನ ಎಲ್ಲ ಆಬ್ಜೆಕ್ಟ್ಸ್ ತಂದು ಕೂಡಿಸ್ಬೇಕು ಕರೆಕ್ಟ್ ಆಗಿ, ರೈಟ್. ದಟ್ ಈಸ್ ವೈ ಐ ಹ್ಯಾವ್ ಕನ್ವರ್ಟೆಡ್ ಎವ್ರಿಥಿಂಗ್ ಇನ್ ಟು ನಾರ್ಮಲೈಸ್ಡ್ ಕೋಆರ್ಡಿನೇಟ್. ಓಕೆ, ರೈಟ್. ಸೊ ಇವಾಗ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ರೈಟ್, ಸೊ ನಂದು ಇವಾಗ ಇಲ್ಲಿ ಕೂಡಿಸ್ಬೇಕು, 4/6 ಕೂಡಿಸ್ಬೇಕು, ರೈಟ್. ಸೊ ನಂದು ಹೈಟ್ ನಂದು ಇದನ್ನ ವಿಡ್ತ್ ನ ನಾರ್ಮಲೈಸ್ ಎಷ್ಟಕ್ಕೆ ಮಾಡಿದೀನಿ 0.4 ಮಾಡಿದೀನಿ, ಇದು 0.6 ಮಾಡಿದೀನಿ. ಸೊ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಇಫ್ ಐ ನೀಡ್ ಟು ಕನ್ವರ್ಟ್, ಇಫ್ ಐ ನೀಡ್ ಟು ಡಿಸ್ಪ್ಲೇ ದಿಸ್ ಇಮೇಜ್ ಇಂಟು ದಿಸ್ ಡಿಸ್ಪ್ಲೇ ಕೋಆರ್ಡಿನೇಟ್, ರೈಟ್. ಸೊ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, 0.4 into 4 ಮಾಡ್ತೀನಿ, right. That will get me the width of the image that I need to display. 0.6 into 6 ಮಾಡ್ತೀನಿ, that will give me the height. Okay. 4 4 16 ಅಂದ್ರೆ 1.6. ಓಕೆ ರೈಟ್. ಅವಾಗ ಏನಾಗುತ್ತೆ, 1.6 ನನಗೆ ವಿಡ್ತ್ ಸಿಗುತ್ತೆ. 0.6 into 6, 6 6 36 ಅಂದ್ರೆ 3.6 ನನಗೆ ಹೈಟ್ ಅಂತ ಆಗುತ್ತೆ. ಅವಾಗ ಈ ತರ ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತೆ ನನ್ನ ಈ ಡಿಸ್ಪ್ಲೇ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಅಲ್ಲಿ, ಅಂದ್ರೆ 4/6 ಇರೋ ಫೋಟೋ ಫ್ರೇಮ್ ಅಲ್ಲಿ. ಅದೇ ನಾನು 8/16 ಬಂದಾಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಈ 0.4 ನಾವಿಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ 8, ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ದ ವಿಡ್ತ್ ನಾರ್ಮಲೈಸ್ ಮಾಡಿರೋದು 0.4. 0.4 into 8 ಮಾಡ್ತೀನಿ. 0.4 into 8 ಅಂದ್ರೆ 32 ಅಂದ್ರೆ 3.2 ಆಯ್ತು. ಸೊ ಇಲ್ಲಿ ಅಪ್ರಾಪ್ರಿಯೇಟ್ ಆಗಿ ಸ್ಕೇಲ್ ಆಗುತ್ತೆ. 3.2 ವಿಡ್ತ್ ಆಗುತ್ತೆ. ಹೈಟ್ ಎಷ್ಟಾಗುತ್ತೆ, 0.6 ಇದೆ. 0.6 into 16 ಎಷ್ಟಾಗುತ್ತೆ, ಅಷ್ಟು ನನಗೆ ಹೈಟ್ ಬರುತ್ತೆ. ಅಂದ್ರೆ ಅಪ್ರಾಪ್ರಿಯೇಟ್ ಆಗಿ ನನಗೆ ಸ್ಕೇಲ್ ಆಗಬೇಕು. ಓಕೆ, ನನ್ನ ಡಿವೈಸ್ ಏನ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಇರುತ್ತೋ, ರೈಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನನ್ನ ಟಿವಿ ಇರುತ್ತೆ, ಓಕೆ ರೈಟ್. ನನ್ನ ಟಿವಿನಲ್ಲಿ ಈಗ 40 ಇಂಚ್ ಒಬ್ರು ಟಿವಿ ಇರುತ್ತೆ, 50 ಇಂಚ್ ಒಬ್ರು ಟಿವಿ ಇರುತ್ತೆ, 44 ಇಂಚ್ ಒಬ್ರು ಟಿವಿ ಇರುತ್ತೆ, 32 ಇಂಚ್ ಒಬ್ರು ಟಿವಿ ಇರುತ್ತೆ, ರೈಟ್. ದಟ್ ಮೀನ್ಸ್ ಡಿಫ್ರೆಂಟ್ ಸೈಜಸ್ ಆಫ್ ದ ಟಿವಿಸ್, ಅಂದ್ರೆ ಡಿಸ್ಪ್ಲೇ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಡಿಫ್ರೆಂಟ್ ಇರುತ್ತೆ. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? 24 ಇಂಚಲ್ಲಿ, ರೈಟ್. ಸೊ ಐ ನೀಡ್ ಟು ಡಿಸ್ಪ್ಲೇ ದಟ್ ಇನ್ ಸಮ್ ಅದರ್ ಸೈಜ್, ರೈಟ್. 32 ಇಂಚಲ್ಲಿ ಬೇರೆ ಸೈಜ್, 40 ಇಂಚಲ್ಲಿ ಅದೇ ಆಬ್ಜೆಕ್ಟ್ ನ ಬೇರೆ ಸೈಜ್ಗೆ ನಾನು ಡಿಸ್ಪ್ಲೇ ಮಾಡಬೇಕು, ಬೇಸ್ಡ್ ಆನ್ ದ ಡಿಸ್ಪ್ಲೇ ಕೋಆರ್ಡಿನೇಟ್ಸ್, ರೈಟ್, ಡಿಸ್ಪ್ಲೇ ಸೈಜ್. ಅದಕ್ಕೆ ವಾಟ್ ಐ ಡೂ, ಬಿಫೋರ್ ಐ ಮೂವ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಇಂಟು ದ display coordinates, right, or I call that as display devices, I will normalize the objects values, so that based on any display coordinates, right, I can manipulate that and I can display that on the respective display devices. Okay, right. So this is what we call it as display coordinates, right. And these are the different process that happens, right, within your camera. ಓಕೆ, ಫಸ್ಟ್ ಎಲ್ಲದನ್ನು ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ, ಯಾವ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಅದು ಕ್ಲೀನ್ ಆಗಿ ಕಾಣಿಸುತ್ತೋ ಅದರಲ್ಲಿ. ದೆನ್ ಇಟ್ ಬ್ರಿಂಗ್ಸ್ ಎವ್ರಿಥಿಂಗ್ ಟು ಎ ಸಿಂಗಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್, ರೈಟ್. ದೆನ್ ಇಟ್ ವಿಲ್ ಆಲ್ಟರ್ ವಾಟ್ ಎವರ್ ಇಟ್ ವಾಂಟ್ಸ್ ಟು ಡೂ ಇನ್ ದ ಫೋಟೋ, ರೈಟ್. ಆಲ್ಟರ್ ಅಂದ್ರೆ, ರೈಟ್, ಯಾವ್ದಾದ್ರು ಆಬ್ಜೆಕ್ಟ್ ನ ಸ್ವಲ್ಪ ಮುಂದಕ್ಕೆ ತರಬೇಕಾ, ಹಿಂದಕ್ಕೆ ತರಬೇಕಾ, ರೈಟ್. ಯಾವ್ದಾದ್ರು ಕೆಲವು ಆಬ್ಜೆಕ್ಟ್ಸ್ ನ, ರೈಟ್, ಇದನ್ನ ಲೀನ್ ಮಾಡ್ಬೇಕಾ, ರೈಟ್. ಸೊ ಏನೇನ್ ಮಾಡ್ಬೇಕು ಎಲ್ಲದನ್ನು ಚೇಂಜಸ್ ಮಾಡ್ಕೊಳುತ್ತೆ, ವಿವಿಂಗ್ ಮತ್ತೆ ಪ್ರೊಜೆಕ್ಷನ್ಸ್ ಎಲ್ಲ ಚೇಂಜ್ ಮಾಡ್ಕೊಳುತ್ತೆ. Then when I say my photo is ready to be displayed, right, so I will convert all the objects that are there in the photo to my normalized coordinates, andre between 0 to 1 to -1 to +1. That is my normalized coordinate. That is one important MCQ question, right. A coordinate system in which, right, all the values will be brought in between 0 to 1 or from -1 to 1 is called as, okay, local coordinate system, world coordinate system, normalized coordinate system, device coordinate system. Okay, this is called as normalized coordinate system, right, where I will normalize all the coordinates of my image between 0 to 1 or -1 to 1, so that I can scale that in my display device to whatever size I want it, right. So finally it moves to device coordinates or display coordinate. Device coordinates I'll display the barathana, that is nothing but device coordinates or display coordinates, right. So based on the size of the display coordinates, right, it gets displayed on the screen. ನೋಡಿ, ಇಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಇನ್ನ ಚಿಕ್ಕದಾಗಿದೆ ಡಿಸ್ಪ್ಲೇ ನಲ್ಲಿ, ಯಾಕೆಂದ್ರೆ ನನ್ನ ಡಿಸ್ಪ್ಲೇ ನನ್ನ ಮಾನಿಟರ್ ಇನ್ನ ಕಮ್ಮಿ ಸೈಜ್ ಇರಬಹುದು. ಓಕೆ, ರೈಟ್. ಸೊ ಇಲ್ಲಿ ಕಮ್ಮಿ ಆಗಿದೆ. ನನ್ನ ಡಿಸ್ಪ್ಲೇ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಅಂದ್ರೆ ನನ್ನ ಸೈಜ್ ಆಫ್ ಮೈ ಡಿಸ್ಪ್ಲೇ ಡಿವೈಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಸ್ಕೇಲ್ ಹಾಕೊಂಡು ಹೋಗುತ್ತೆ ಆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಸೈಜ್ಗೆ, ರೈಟ್. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ phenomena. Okay, right. See, this much of activities, right, happens inside your camera. Okay, right. Our drivers anta ಏನು ಹೇಳ್ತೀವಿ, ಡಿವೈಸ್ ಡ್ರೈವರ್ಸ್ ಅಂತ, ರೈಟ್. ಸೊ the significance of drivers is this. Okay, right. ನಾವು ಇವಾಗ 8/6 to ಇದು ಶೀಟ್ ಇಟ್ರು ನಮಗೆ ಫೋಟೋ ಬರುತ್ತೆ, ರೈಟ್. 4/6 ಶೀಟ್ ಇಟ್ರು ಫೋಟೋ ಬರುತ್ತೆ, ಪಾಸ್ಪೋರ್ಟ್ ಸೈಜ್ ಇಟ್ರು ಬರುತ್ತೆ, ಸ್ಟಾಂಪ್ ಸೈಜ್ ಇಟ್ರು ಬರುತ್ತೆ. ಹೆಂಗ್ ಬರುತ್ತೆ ಅದು, ಏನು ಅದ್ರ ಪ್ರಪೋರ್ಷನೇಟ್ ಆಗೇ ಬರ್ತಾ ಹೋಗುತ್ತೆ, ರೈಟ್. ಹೆಂಗ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಹಿಂಗೆ ಬರೋದು, ಎಲ್ಲದು ನಾರ್ಮಲೈಸ್ಡ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಆಗಿ ಸೇವ್ ಆಗಿರುತ್ತೆ. ನೀವು ಯಾವ ಡಿಸ್ಪ್ಲೇ ಡಿವೈಸ್ ನ ಇಡ್ತಿರೋ, ಡಿಸ್ಪ್ಲೇ ಡಿವೈಸ್ ಅಂದ್ರೆ ಯಾವ ಸೈಜಿನ ಫೋಟೋ ಫಿಲ್ಮ್ ನ ಇಡ್ತಿರೋ, ರೈಟ್, ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೋಟೋ ಫಿಲ್ಮ್ ಡಿವೈಸ್ಗೆ ಅದು ಸ್ಕೇಲ್ ಆಗಿ ಬರುತ್ತೆ. ಅಲ್ಲಿ ನೋಡ್ತೀರಾ ಆಪ್ಷನ್ ಕೊಡ್ತೀವಿ ನಾವು ಪ್ರಿಂಟ್ ಕೊಡ್ಬೇಕಾದ್ರೆ, ರೈಟ್, ಏನ್ ಸೈಜು ಅಂತ. ಓಕೆ, A4 A3ನ, ರೈಟ್, ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ಟು ವರ್ಡ್ ಡಾಕ್ಯುಮೆಂಟ್. ಓಕೆ, ಅದೇ ತರ ಫೋಟೋ ಹೋದಾಗ, ರೈಟ್, ನಾವು ಸ್ಕೇಲ್ ಕೊಡ್ತೀವಿ ಅದಕ್ಕೆ, ಪಾಸ್ಪೋರ್ಟ್ ಸೈಜ್, ಸ್ಟಾಂಪ್ ಸೈಜ್, 4/6 8/16 ಅಂತ, ರೈಟ್. ಸೊ ಇಟ್ ವಿಲ್ ಟೇಕ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್, ಇಟ್ ವಿಲ್ ಮಲ್ಟಿಪ್ಲೈ the local coordinates with that coordinates and it will give the image. Okay, right. So this is what this is how, right, I convert my local coordinates into device, finally into device coordinates. Okay, this is a very important question in this model, in this module, right. Explain the transformation from local coordinates to device coordinates. Okay. So this is the end of today's class, right. So coming to the next class,